Test, test, test. Hey, the microphone works. I think we're live. Hey, friends. Wow, okay. Sorry about the delay there. I think we finally figured out the stream. Okay, hey, how's it going, everybody? Yeah, my name's Andrew. Welcome to Code Gets Creative. This is the debut stream. I think it's only fair that we should have like a few challenges setting this thing up for the first time. Some of the challenges include I'm using this service called Restream that actually sends the stream both to Twitch and to YouTube at the same time. I don't know which one is going to like work out more, and so I'll send it to both for a little while, and we'll see how it goes. So that struggled a little bit. Meanwhile, trying to get like background music plus my microphone to all go to the same place at the same time was like a bit of a challenge. I think that's finally working. On the other hand, I'm hearing like a little bit of an audio delay when I monitor it through my headphones. So in order to compensate for that, I'm just like turning it off in my monitors when I don't need it. And I'll fix that later. So we'll figure it out. But enough about problems. Let's talk about like the stream and like the channel and what we actually want to do with this thing. And yeah, hopefully it'll be a really cool experience. Yeah, so my name's Andrew. I'm based in Utah, in Vineyard, Utah, which is like 30 to 45 minutes south if you're driving from Salt Lake City. I'm a professional software engineer. So I work at a company up in Lehi, Utah called Podium, a very cool company that does communication tools for local businesses. If you're ever curious about that kind of stuff, you can hit me up in direct messages and I can tell you more. For the most part, I'm not going to be talking about like my employer. This is going to be more about creative projects and creative coding and kind of the things that we don't normally like get paid to do. It's the stuff that we get to program for fun. And I'm excited about that. Other kind of history about myself. Let's see. I actually co-founded a startup several years ago. Tried doing that for a little while. We pivoted several times and we called ourselves Pivot Labs, which I think is fair. We tried building everything from a batch crowdfunding platform to a kind of like a pre-crowdfunding platform for marketing to a to-do app to a email client, which is when I got out of there. We ate ramen noodles for a long time and it was difficult, but it was a really cool experience. And I learned out of that actually that I prefer working for the man. I like the stability and I like how there's enough autonomy to have fun and do things and then leave it at the office. And that lets me come home and like do fun stuff like this in my free time. And you know, do all the inventor stuff that I maybe wouldn't get to do otherwise if all of my time and all of my attention were devoted to starting a company. So kind of cool. Outside of coding, I really love music. I play synths. You can see a bunch of synths behind me. We'll be using these in future streams. So up here, we've got what's called a Eurorack format synthesizer. It's a modular synth, which means that instead of a single box, let's talk about the other synth first. This is called the Dave Smith Instruments Prophet Rev 2. Very cool synth. It's analog. It's polyphonic, so you can play lots of notes at the same time. But then this one is a modular synth. So instead of a single box that does everything, it's made up of a lot of modules that are each behind its own panel. And in order to tell the synth what to do and what sound to make, you're actually plugging these cables together. And by patching that up, you're programming it to do something. And fun fact, before digital computing was really a thing, computing was done analog through basically this type of interface, and music synthesizers followed suit. Like this is basically an analog computer that happens to make sound. So fun facts. So yeah, we'll be doing stuff with synths in future streams for sure. And I've I've done some projects with synths, and we'll be talking about those. So yeah, love synths. Play drums, play a little bit of classical piano. I need to get better at classical piano, but that's like probably like a lifelong pursuit that maybe like many people are thinking about. Yeah, so that's music. I love visual art. I am not very strong at visual art, or maybe in particular, I can't do like freehand line drawing or painting, but that's okay. Visual art can still be a lot of different things, and one of those things is generative art, right? And I love generative art a lot, and we will be talking about generative art today and on future streams. And the cool thing about generative art is that there's like a different set of skills. So you have to be thinking about a lot of artistic properties of like creating a piece. You're thinking about color, you're thinking about form, you're thinking about composition. But there's less virtuosity in terms of what your hand is doing, and less about that skill and more about the knowledge of kind of what do we want the computer to do, and then we turn it over to the computer and it does it, and the computer becomes kind of like our co-collaborator in making art. And so yeah, that's kind of a different skill set, and we'll be doing some of that. So in general, love combining technology and art, and that's really why we're here. We want to do creative coding. So why this channel? I think two reasons. Reason number one, I love doing projects. Projects are an excuse to learn new skills. That's so important working in technology. I've heard before that the half-life of all knowledge in technology is about 2 years. In other words, like whatever you've learned about technology, half of it's not relevant anymore, or at least not like fully relevant in just 2 years, and you've got to go retool. And so really that's happening all the time, and doing fun projects on the side helps us kind of stay current, right? But above that, like it's also a chance to be creative. It's meditative. It's refreshing. It's relaxing. It's an opportunity to just do fun things. It just feels good, you know. And it's a chance to build whatever I want, because when we're at work, whatever our boss needs us to make, we're making that, and there's plenty of creativity that goes into that. But there are more constraints to it, and getting to kind of choose what we're working on and how we do it opens that up a little bit more, so that we can explore more. So I like that. Doing projects is cool. The second reason, though, is I really love teaching and sharing ideas. And this is like really kind of deeply special to me. I think it's a chance to give back. I genuinely feel like I'm just really fortunate and really kind of privileged to have had the opportunities that I've had to try starting a company, try and fail at that and still be like financially okay. And to be in a good position to like be working at a comfortable job today, when I know there are plenty of other people that may be struggling financially, and so I'm really grateful for that. Like I've got skills and knowledge, but also like these opportunities that I've had, and there's something about kind of paying it forward that I think that we can do on channels like these. So I hope that this isn't just like all about like look at Andrew and Andrew's projects, whatever. I want it to be about like how can we all learn something new. So if you've got something specific that you want to learn or that you want to explore, let me know through chat or through DMs or whatever, and we can explore those things. I want this to be genuinely like a cool resource that you can come to and like pay it forward in that way. Looking forward into the future, I'm actually interested in teaching part-time or full-time. And I don't know when that'll be. That could be like a good 20 years from now, probably 20, 25 years from now. But eventually that's where I want to be. Because I'm just passionate about kind of sharing the opportunities that I've had and the knowledge that I've got to enjoy with other people. And I've been able to do that like a little bit on a volunteer basis. So like there's been an opportunity. Hold on. Something just occurred to me. this occurred to me. We had to turn the sound back on, or turn the beats back on. We got to get this monitoring figured out, you guys. So yeah, I've had chances to teach on a volunteer basis in the past. That's through like code camps, through activities at my church, through something called the Utah Refugee Education and Training Center. That's through the Utah Department of Workforce Services. So those have been really cool opportunities. I encourage each of you, really, if you're interested in like, you know, if you're also in software and you love this stuff and you do this stuff, try volunteering as well, and try finding ways to like pay it forward and pass this stuff on. This is just one way that I'm finding that I can kind of pay it forward. So that's why I want to do this. I'm excited about it. So who am I kind of directing this for? I guess like anyone who codes, maybe. That's probably like, you know, vague enough that like there's an enormous range of skills. There's an enormous range of like industries. So I think that we're going to narrow this down a little bit in terms of like, we'll talk about some beginner stuff and some more advanced stuff. I don't want to like commit to that decision yet. But I think we'll land on something. And I want to do like a little bit of both because it's just fun and refreshing that way. And really anyone who wants to get into coding and recognizes it as a way to kind of bridge technology and art, in a way to maybe take like artistic ability and then leverage technology to get even more out of it. I'm really excited about that aspect. I've got some friends that do art, do music, and I'm really excited to collaborate with them on projects because it gives all of us kind of a chance to like share these ideas and share different fields with each other. And on top of kind of people to collaborate with or people to learn, I'm hoping that this is an opportunity to get inspired and to do your own projects, right? This has an opportunity to kind of turn into a community where we're learning from each other. We're showing projects off to each other in a way that inspires us. So that's cool. I think that if I don't keep the music open in a tab that's like visible, it doesn't go to the next song. So now I know. And so now I'm going to tear off this tab and I'm going to put it in the corner of a desktop that you can't see. Here we go. And hopefully it's going to keep playing. Thank you for bearing with me. I'm going to figure out all of this stuff. And it'll be real cool. Okay. Let's talk about some projects. And then let's do some live coding. I think that'll be cool. Let's see. First project I want to show. Basically, I want to show just a handful of projects that I've done in the past so that you can see kind of what I'm interested in, what this channel might look like, and then we'll talk about future projects. Some of the things that I've got like immediately upcoming, and then some other things that I'm kind of thinking like longer term out, building some of that stuff. So let me start by showing you a project. Let's see if this worked. Did it work? Oh, yeah, it didn't work. I just clicked on something and it opened the wrong browser in the wrong place. So we've got to fix that real quick. Let's see. Copy. Paste. And then here we go. We're going to switch over to... Boom! We did it. So, okay, I managed to operate OBS. I'm so proud of myself. So what we're looking at here is a project that I did collaborating with a good friend of mine named Mike, aka Grover Tunes, on this interactive web comic called Deeply Dave. Deeply Dave is awesome. It's this kind of passion project that Mike has had for a few years, and working together, we figured out that we could take this webcomic that he had as a concept and take it from kind of a static experience where you're scrolling through panels, but make it more interactive. So you can see there's this cool parallax effect where the elements in this image actually move like independent of each other. You'll notice it's all animated. These are all GIFs. That's Mike's magic that he's working. He's an animator by trade. But yeah, the really cool stuff starts as we read these episodes. So let me pause the beats, and I want to show you episode 1. We're not going to actually like read through this comic, but you're going to get the idea of like how the music works. Oh yeah. So you can hear the soundtrack is going now. And as we start scrolling through this, the soundtrack kind of sets the mood for this mysterious, like, underwater scene. Roll the title, episode 1. And here's Dave. Real creepy. He's trying to figure out what's going on. Beware. And the strange talking fish kind of, sets the stage. But as we start scrolling through this is actually an interactive comic. And by the way, you got to go read this on your own. That's one of your homework assignments, I guess. I'm just gonna slowly back away, and you'll notice that when we hit this panel, the soundtrack changed. So this comic is behaving in the same way as a video game, where you're in the town and you get one part of the soundtrack, and then you start battling and it's a different set of the soundtrack, right? So this comic is kind of written and built in that way. So very cool project. All right, we're gonna have to come back to that later, but Deeply Dave, that's one of the projects that we've talked about, and this is ongoing. So you'll notice that so far episode 1 and episode 2 have been released. 3 is probably going to come out a month from now. No promises. Mike is working on the content for it. But yeah, very cool story. Very, very cool piece of art. Here, let me drop this in the chat so everybody can get to it. Hopefully that sent. Maybe thumbs up, and if somebody in chat could give me a thumbs up that actually showed up. I used Restream, so hopefully that got blasted out to both Twitch and YouTube. Yeah, we will see. It's here. Awesome. Thank you, the gentle honeybee. Appreciate it. Cool. So, Deeply Dave. Let's look at just a couple more. Next one I want to show you. It's got a boring like internal name, and it's got a working title that I think we're going to keep. We'll see. So let me show it to you. This is the Synth Transformer box, also known as the Universal Traveler. By the way, let's press play on this again. Yeah, nice. So what does this actually do? This is basically a little device that's going to sit in the music studio and translate between MIDI messages that are happening on a digital audio workstation, or a DAW. So this is software like Ableton Live or Logic or Pro Tools, software that makes music, but then it translates it, and this is all like modern software, right? Very, very like state of the art. Everybody uses this software. But it translates those messages into kind of the more like old school various versions of the MIDI protocol that old 80s era synthesizers use. So MIDI stands for Musical Instrument Digital Interface. It's still the de facto standard for kind of how synthesizers talk to each other digitally. And it hasn't changed too much over the last several decades. But what has changed is that synthesizers are kind of more standard about how they use it, how they expect those messages to come in. And so those more vintage synthesizers, you actually need something to kind of translate that a little bit. And so this is a box that my friend Eric is going to use in his studio. I'll show his website in just a second. But this is something that's going to help him kind of power his studio and get more out of the vintage synths that he has, so that he can use it in film and use it with his band New Shack. Look them up, by the way; they're super cool. And yeah, like do more cool things, like more modern cool things with retro synths. Let's see. So here is the Synth Transformer box, if anybody wants to link to that. This is still, early days. Looks like I need to fix a security vulnerability with a dependency. Don't use this in your studio till I fix the vulnerability, I guess. It's going to be a minor thing, like I don't know, like prototype pollution in a JavaScript library that's not actually like it's theoretically possible, but you can't actually do it, kind of thing. So we'll fix it. But anyway, this is the Synth Transformer box. This chip right here is a Teensy 4.1, which, if you've heard of Arduino, it's pretty similar. It's a microcontroller, so we're writing C++ code to power this thing. We've got a little LCD screen, we've got a button to switch between presets, and then here is a USB input. So MIDI signals are coming in over USB right here, and then MIDI signals are going out to a splitter that goes to a bunch of vintage synths right here. And eventually we'll build this into like a cool enclosure. We'll use CAD and we'll do all that good stuff. Maybe this will like turn into a product and more people will use it. But in the meantime, it looks like this, and it's kind of open heart surgery on a breadboard, and it is what it is for right now. So yeah, cool. That's that. Let's see. Let me show you a generative sketch. I think that'll be cool. Copy the link address. So I'm gonna get this all queued up. This is on YouTube. If you look on my YouTube channel, this is called a generative sketch. And what you're about to see is made in Blender, combined with my modular synth. So I made a patch that's very random sounding in my synth, and then I wrote a little bit of code in Rust and in Python to extract the timing information from that. Extract basically like when does everything happen, and then every time a note happens, one of these little glowy cubes appears. So that's what you're about to see. Watch this. Nice. Yeah, so there you go. That's one of two generative sketches that we have so far. So you could probably kind of guess what that algorithm was. There's basically a circle where the center of that circle is kind of the home base. It's the starting point, and then it randomly kind of picks a direction and tries to place a cube there. And if there's already a cube there, it'll skip it and find somewhere else. But it just kind of grows from that center place. And it's only going to place a cube when a note happens. So really cool. Very, very like reactive to the music that happens. Speaking of which, gotta get the beats back on. Let's see, I should send the link for that in case anybody wants to see that. Boom, there we go. Okay. So yeah, we've looked at a few kind of cool projects. Actually, let me show you one more. This is just plugged into my computer, so I'm gonna like carefully unplug it. Here we go. So what you're looking at, what you're looking at here is a little macro keyboard. This also happens to be a Teensy microcontroller. This is a Teensy LC. LC is low cost. And these two fun, clicky little arcade buttons. Here, we'll do some ASMR arcade buttons. Oh yeah, wonderful. These two little arcade buttons are actually keyboard keys. So as far as my computer is concerned, this is a keyboard. It's not an arcade game or whatever. It's actually like a second keyboard that's plugged into my computer. And this one is play and pause, so I can like, turn music on and off. And then this one actually mutes and unmutes myself on Zoom, so that when I'm in virtual meetings with my coworkers, I can like speak at the right times. Which I'm working from home these days, and I'm on Zoom calls every day, and this is very useful. I get a ton of use out of this thing. So yeah, C++ code on this box, and then a little bit of soldering to get all this connected, and then this enclosure is actually designed using a tool called OpenSCAD. And OpenSCAD, if you're not familiar with it, it's pretty cool. Let me do a quick search for it. Yeah, here we go. The Programmer's Solid 3D CAD Modeler. So the way this works, let me just like, I don't know, open this up and make it bigger. Basic idea is you write this code on the left, and it actually turns into geometric shapes on the right, like three-dimensional shapes. And you can see that like there are concepts that come from computer-aided design, like linear extrude or intersection, intersection between shapes. Translate, right? There's variables, but then there's all these, like import a DXF file, or I think DXF dim is probably a built-in function that like does stuff, whatever. So this is really powerful. Like you can actually procedurally generate models using this code, and that turns out to be like a really good way to build this kind of stuff, because it's all like, it's simple and it's all made of just simple shapes, right? So the way I did it is I basically described using text where this shape should be, and then I extruded it, so I turned it from 2D into 3D, and then I chopped out the inside, and then chopped out these two circles, so that I could build this into an enclosure. So yeah, that's how that worked. And it's a great way to build project enclosures for these little like Internet of Things type projects and other electronics. So very cool stuff. Okay, let's talk about future projects. I've got a couple that I'm working on right now that I think will be like streaming soon. First one is, let me pull it up. So I use a tool called Element on virtual calls, on like I'm using it right now actually to add a little bit of dynamic range compression to like clean up the audio quality for my microphone. So it's a very cool tool. It's actually missing a plugin to do what's called gate. So basically when the sound is quiet, it just mutes it, or it lowers it. And then when the volume gets louder, it's normal. And that's good for like removing my computer fan, for example. You can probably hear that just a little bit in the background. And so it's missing a gate plugin. So I've started working on adding one of those, and we'll actually contribute that back to Element as a pull request. And that'll be a cool, bit of open source contribution from the channel. So that's cool. Another thing that I'm working on is I want to learn some DSP. That's digital signal processing. So we've got this chip right here. This is called a daisy seed. Sorry, this is a daisy seed. It's plugged into a daisy pod. Yes, that's written down here. And basically, this is a chip. It's a microcontroller, kind of like Teensy or Arduino. It's like specifically designed for audio applications. So it's got like a really high quality digital to analog converter and like audio codec. It's got a pretty beefy processor, so you can do, like intense math on it at speeds that are fast enough to like generate synth sounds and stuff. Yeah, so far I don't have a whole lot to show for my work on this, but like I can generate some simple tones and that kind of stuff. I want to build like an FM synthesizer or like a drum machine, or maybe like a cool practice tool that like as you're playing synths or piano or something, this is like your kind of one click, one button press drum machine. I think that'd be like a cool project. So yeah, that's the Daisy DSP. I'll drop a link to that in the channel as well. Let's look that up real fast. Yeah, here it is, in case anyone's curious. Cool. So we want to do some stuff with that. And let's see. On top of that, there's some generative animation that I'm working on that I should get that fired up. Let's switch over to a terminal. Come on, Bash, let's go. My Bash is being slow. Cool. Where does that live? I'm like getting distracted by like hosting the stream, and I'm not like thinking straight. Beats are still going though. Just checked. Just added a monitoring back for a second. Good times. Okay, I think it's in portfolio site. Yeah, there it is. Cool. So let's get this fired up. Oh, hold on a second. Are we already running this? It's right here. Okay, we're gonna make our lives a little bit easier. I've already got it in a tab. So we'll do this thing. Ooh. We're gonna have to stash some stuff. Working on tree layout. Shoot, what was it? This is good. This is what the stream will actually be like most of the time. It's not gonna be like me just monologuing. It's gonna be like looking at a terminal or looking at code. So, wow, good. Hope everybody like feels something in their hearts right now, because I certainly do. So let's just do this. What are we actually changing here? Oh, yeah. We're trying to like, yeah, we added this like post order visiting to trees. Okay. Git, stash, save. And this is basically like better rendering for tree layout. Cool. We'll call that good. So now our code should actually compile. And some of you, depending on kind of your background in different languages, you might have seen that and been like, hold on, that looked kind of weird. What we're looking at here is actually, NPM, which is the package manager and task runner for Node, for JavaScript. And when we run this command, it actually switches languages on us. So this is actually Rust code. And by the way, this is Rust code with a whole lot of compile time warnings, because I'm busy switching from one big chunk of code to another. And so it's very noisy right now in the console. But what this is doing is it's actually creating WebAssembly. WebAssembly is a way that you can create binaries for the web and then run them in your browser instead of JavaScript. So we've always talked about JavaScript as being like the language of the browser, the language of the web. WebAssembly is kind of changing that. And so this project is cool, among other reasons, because it's an excuse to like hack on WebAssembly and try it out and see like what's the experience of building for WebAssembly and getting it deployed on a web page and stuff like that. But what does it actually look like, you may ask? That looks like this. Cool. Yeah, here's one layout. You'll notice it's this like tree structure of just like random stuff. And when I refresh it, it like changes a little bit. Yeah. Maybe that's kind of underwhelming for right now. That's okay. We're halfway through the project. But yeah, this is like a tree layout that really is just kind of showing like randomness, and it's using a color palette that actually comes from P.A. Mondrian's compositions, which now we have to go look up because this is some of my favorite abstract art ever. Yeah, it's this kind of stuff. And there's one, yeah, it's this one. This one in particular, I love this one. I love this one so much that I teamed up with my mom and we took this design and we actually made it into a quilt pattern. And that quilt pattern is actually hanging up downstairs in my house. And I'll have to get a picture of that and like show it on the stream one of these days because it's very cool, and my mom deserves the credit for like creating this awesome quilt out of some, out of a painting. So that's cool. But I love the color scheme here, and I love kind of the exploration of form here, right? And of composition in abstract. Like what if the composition was like abstracted to the point where that was the whole piece? That's kind of what this is all about. Very cool stuff. Yeah, so that's where these colors come from. let me show you. I'm gonna like tweak the code just a little bit, and hopefully it won't blow up on us. But I want to show you another layout, and I can kind of describe what it's supposed to be doing. And then in a future stream, we can work on this and we can build it out so it actually does the thing. But we've got a tree layout and we've also got a grid layout. So let's save that, and it'll hot reload in just a sec. There we go. Okay. So this looks a lot cooler. I think it feels a little bit more like visual art at this point and not like a big mess. But that's okay. We're gonna get the tree layout to the same level of like quality soon. But you'll notice like we've got this grid of random colors, same color palette. If I hit refresh, it'll like randomize it all over again. And you'll notice that it animates, right? Like it fades in, so that's pretty cool. It fades in one at a time, so you can see like this guy's gonna come in before these, and it gradually comes in, whatever. Feels nice. But the general idea here is that I want to have a bunch of these layouts and then transition between them. So we'll start by fading into this grid layout, but then we've always got 24 of these squares, these rectangles. They happen to be squares right now. And then once it's shown this grid for a little while, then it's gonna calculate a tree layout, and then each of these rectangles is gonna move into a new place, and it's gonna become part of this tree layout. And then once that's over with, it's gonna switch to some third layout, and everything's gonna move to that. And it should be this really cool kind of fluid, like morphing between these different layouts and these different ideas. The thing that I'm trying to get across with it is that like this is me, this is Andrew. Like I love code, I love art, I love organization, I love processes, and so these different layouts are supposed to sort of like represent that. I want to do another layout that's basically Mondrian compositions. So can we write a computer program that auto-generates layouts that look like this, with the additional constraint that there have to be exactly 24 rectangles inside. So yeah, I think that'll be a really cool thing. And then like, I think I'll put it up on my website, and that'll be like the thing that you see, you know, when you first land there. Cool. Okay, we've done a little bit of that. I think now that we've looked at a few projects that we'll like, you know, we'll do in the future, we'll dive into them in the future. Let's just do something kind of simple right now. I think that'll be cool. And in order to do that, I'm actually going to get something out of the closet that belongs to my synthesizers. So give me just a moment to do that. And I'm gonna switch some things over to do that. Okay, so here's my face, and then I'm gonna click this button. Haha, but I think you can still hear me. So that's kind of cool. Okay, I'll be right back. I'm gonna grab some synth stuff and I'll show it to you, and we'll write some code based on it. Found it. All right, we're back. Yeah, so let me show this off. We got our Tupperware of synthesizers, kits, and parts. Remember to label all your stuff and keep it organized. For your own sanity and for your significant other's sanity, keep your stuff organized. Let's see. Inside of this, we got some goodies. Here's like a kit for a module that I need to build someday. Here's some like random components. This happens all the time when you finish a synth. Like each of these kits tends to come with like one extra resistor of every value, one extra capacitor, one extra like knob. In some cases, there's like a knob right there. So you end up with a bunch of these, and they become useful if you like burn something out. You can like reach into here. But let me show you this. Yeah, this is what I wanted to show you all. So thank you for your patience while I got this metal square. So this is called a blind panel, and it's really just like a blank piece of metal with some holes drilled in it for screws. And what this is for is you put it in your synthesizer in spaces where you don't have a module, and that way it keeps the dust out and it keeps it safe. But it's also a chance to like express yourself, right? And I think the message that I'm sending when I have this in my synth is I'm getting the job done. I'm keeping dust out of my synth. You know, I'm an industrialist or like I'm a pragmatist. But there are some people that actually design like really beautiful blind panels that have designs on them and look really cool and kind of give a little bit of personality to your synth. There, put that away. So what I want to try is writing a bit of code to generate patterns that go on blind panels. Let's actually, I think Make Noise has some cool ones. Let's check real quick. Yeah, look how cool this is. So, yeah, I mean, it's just a hunk of metal, right? But it looks awesome. Like, I love this visual design. And it comes in different sizes, yeah. I think Synth has another cool one. This is just to kind of get some ideas for how this might look. Here we go to Reverb. This is kind of cool. This serves an extra purpose in that it's actually like a printed circuit board. And so you can actually like, these are conductive leads on here. And you can even like, I don't know, if you're a crazy person, you could solder them. You can also like drill into them and like change their shape. But I think they look awesome. Like, I don't know, look how cool that is. So, let's do some of this kind of stuff. I think it'll be cool. And I think we're gonna go to like 8:30 Mountain Time. We can go for like 30 minutes. Should be cool. Oh, pictures. Thank you, Cressula Rupestris. I appreciate that. Apparently I've been monologuing with the wrong OBS scene this whole time. Let me show you what we're actually talking about. This is what I have been looking at as the rest of you have been watching me monologue. This is a company called Make Noise. Their blank panel looks like this. I guess they call it a blank panel. SynthroTech calls it a blind panel. And you can see like it's just like a big, slab of metal, but it's got this like really cool design on the front. Now let's look at that SynthroTech one really quick. Go to Reverb. Yeah, and check this out. Like it's a printed circuit board, right? Comes in different sizes and shapes. But like I love that pattern on it. These kind of like diamonds or like, these lines that are going across it. So imagine how cool it would be if we could write a program that could just randomly generate something like this and then print off like 100 of these, and sell them or give them to 100 synth friends in the Salt Lake City Synth Alliance. Look them up, by the way. Like that'd be really cool. It's sort of the same experience as like having print 5 of 100 of an original piece of art or that kind of thing. Like there's the scarcity to it and there's this uniqueness to it that makes it special. So I like that. I'm thinking what we can do is we can use P5.js in order to build this thing. It's really good for a lot of things. Let's maybe just like scroll through this. If you're not familiar with this, yeah, P5.js is a JavaScript library for creative coding with a focus on making coding accessible and inclusive for all of these cool people. The basic idea, yeah, you make a sketch and your sketch knows how to draw stuff, and then you can like export it or you can do stuff to it. You can do all kinds of cool things in it. One of the things that's really nice about it is P5 actually has this like built-in web editor, so you can just write code and press play, and it'll just run it right in the browser. So you don't have to run all your fancy compilers to turn things into ones and zeros. Like your browser's doing all the lifting for you, and you don't have to like set up all that infrastructure type stuff. You can just start making art. So that's good. We probably need to like do a little bit of design work before we start writing code though. So how about we do this? Yeah, this is a very cool website called excalidraw.com. It's a great prototyping tool. You can do collaborative editing inside of it. So think like Google Docs, where like everybody can make edits at the same time. And you'll notice that I've already got some stuff randomly in this session that are going to be layouts for that generative animation. So like, here's the tree layout, here's the Mondrian layout. Maybe we might do like a flow diagram layout where we've got like boxes and diagrams, or diamonds. That's the word. And think how cool that would be if you've got like a rectangle and then it like reshapes itself into a diamond as part of that animation. So that'll be cool. We got these little like abstract code concept. So anyway, let's actually do the like Eurorack panel though, yeah? So I'll just scroll to kind of a blank spot so I can keep both. And I don't think we need to be super like scientific yet about the actual shape. So I'm just gonna kind of like block it out. We've basically got like the blind panel. We'll go with like 20 HP. 20 HP means 20 horizontal pitch, which is, I already put it away. It's basically like a unit of measurement for how wide one of these modules is. And we can look it up. It's a certain number of millimeters. But 20 HP means you've got 20 of those units going across, right? And that's going to fit into a certain size of box or a certain like size of blank space. And if we're clever about this, we can make our algorithm in a way that like you can maybe just type in a number for how many HP wide is your module, and then it'll figure out like, oh, the canvas should be this big and all the shapes should like fit into these constraints. So that's cool. We can do that. We've got holes for screws that go right here. Drop those in. I'm not being like, this is not very like scientific, right? This is really just to get the idea across. So great, now all we have to do is make art. I've got a couple ideas here, and like chat, if you've got any ideas, feel free to shout them out in chat as well. Something I was thinking of doing though is for modular synths, you're patching everything with these cables, right? So if I were to grab these, I don't know, we've got like different colors of cables. We've got different sizes of cables as well. And you end up like, you end up like twisting them all around, and they end up in all these funny shapes. You can see it over here. Here, I gotta switch back over to, like, you can see that like, it looks like a real bird's nest in there. And that's just kind of like how modular synths end up looking as you patch them. And there's something kind of aesthetic to that. You know what I mean? Like all these cables like going every which way, that's like part of the personality of modular. So maybe there's some way that we can like express that through the blind panel. I gotta shift some things around. So maybe what that might look like is I'll just like start placing stuff. I can like do this kind of thing. Oh, escape or enter to finish. There you go. Nice. So we can like, kind of tweak this a little bit. But what if we have a bunch of these where, you've got these cables and they're going from one side of the panel to the other. Maybe I'll tweak that just a little bit. Add a couple more to kind of get the idea across. And notice notice where I'm clicking, right? So I clicked on the edge, and then here, which is like horizontally out from that edge. And then I'm like kind of picking, let's say it's going to go into here. I'm going to like click here and then here, and then finish that. And so we end up with this like cable that's kind of coming out from the edges. We're creating this kind of funny like tangent between these two. So I don't know. We'll move it up here. There. Now this looks symmetrical. This is like the curse of generative art, is like you end up with, I don't know. You end up with stuff, but whatever. We can do this kind of stuff, I think. And then maybe we scale it up, right? So instead of just 4 of these, we've got like 100 of these all like crammed into a single panel. I think that'll be cool. So in order to do that, let's see, I think we're gonna want this open, and we're gonna want the reference, P5JS reference. There we go. So we'll know all the cheat codes to type in. These are the cheat codes. Yeah, and let's see what we can do. So maybe we can start by like building out this canvas. So if we run it like this, boom, here's what that looks like. We can start by making this quite a bit bigger. So there we go. And I think it's not quite square, so maybe we change the width to like 750. Something like that. And then we can just start drawing stuff. So let's try to draw like a rectangle for the top, rectangle for the bottom, and we'll just leave it at that. Like it'll get the idea across. And then we can start doing these swooshes. And we'll definitely have a function called swoosh. So let's see, we want to make a rectangle. I think it's just rect, yeah. And it's X, Y, width, and height, yeah. Cool, so let's do like rect, and we can do it from like, it's X and Y, so we'll do like 0, 100. Oh no, this is the very top. So 0, 0 to, we want to go all the way across, so that's a width of 750, and then a height of, we just got to kind of guess, like let's say 50 for now. Okay, so it's a white rectangle with a black border, black stroke. If I remember, their function's called stroke. Yeah, so stroke, and then you give it a color. And then I think there's also fill. Yep. Okay, so let's say stroke. Actually, I think there's one called no stroke, which maybe we want in this case. Yeah. We just say no stroke. And then fill, I think we can say like that. Yeah, there we go. So we've got the hex code for just all black. We can put that there. Cool. So we've got our top rectangle. Now we can do our bottom rectangle. Width and height are going to stay the same. The y coordinate should change though. So that should be what, 750? There we go. Run that. And now I think this is kind of an opportunity to refactor a little bit. Refactoring, if you're not familiar with refactoring, it's the idea of like, you're going to make your code continue to do the same thing. It's just going to be cleaner code. So what I'm going to do here is I'm going to refactor it so that a bunch of these numbers are going to become constants that live up at the top of this file. And that way it makes it easier to kind of tweak things and like resize our module or tweak like the randomness kind of parameters, that kind of stuff. So let's do like canvas width. I think that'll be good. And that's basically this number, right? And then, oh, sorry. Canvas width is not 800, it is 750. Canvas height is 800. 800. So this should be canvas height, this should be canvas width. And then this rectangle is right here, and we're crossing the whole canvas width. So that should be that. And then right here, we're going across the canvas width. And then we are, I think we've got another constant here, which is like what do we want to call the height of this? We could call it like outer margin or something. And so now we can say this is, you know, the outer margin, and then right here, this is canvas height minus outer margin. So when I click play, this should look identical. Phew, and it does. Okay, so we successfully refactored. So now at this point, we can actually like put some cool stuff in here. I think in order to get to this point, let's see, there's a few things we need to do. We need Bezier curves. So Bezier curves are just like, you know, curvy lines as opposed to straight lines. I think we can like hard code them for now and just like get them rendering so that we know that they're like looking the way we expect. And then I think what we can do is maybe we can, like, to keep things simple, I think we can make an array of numbers for the left, an array of numbers for the right, and then we just shuffle each of them. You end up with parallel arrays, which is like kind of awkward, but there are fancier things that we can do, but we're having fun. We're just experimenting. So let's give it a try. So we need to figure out how to make a Bezier curve. Let's see. Yeah, this is what we want. So got a Bezier curve from here to here. 85, 20, so this should be, that's probably this point, right? 85 across, 20 down. Yeah. And then it looks like it's there. Okay, there are anchor points. There's anchor point, control point, control point, anchor point. And then I guess you can do it in 3 dimensions if that applies. Okay. So, oh, notice also we need to add stroke back. So let's do that right here. Stroke, and we can do alt black for the stroke. And then we need a Bezier curve. And let's do like from here to here, something like that. So we'll say from 0, 100. And now we need a control point like right here. So I think we want to just be like, we want to go straight across. So let's say like 200, 100. Right, going out 200, we're staying the same height. And then let's say we're going down to like 300, something like that. So the next control point should be, what, 7? Well, it should be canvas width minus 200, comma 300. And then it should be canvas width, comma 300. Okay, cool. So we rendered a thing. You'll notice it's interpreting it as a polygon rather than just a line. So we need to figure out how to turn that off. Oh, it's probably just no fill, yeah. So if we run this again, yeah, perfect. So we have our first swoosh. Okay, so let's make the swoosh function, yeah? And I think the only parameters really, like, a lot of these x values are constant. And so it's really just the y values. It's like the y value on the left, the y value on the right, and that's it. So I think the input parameters are just y1, y2, and everything else is derived. So we'll put parameters in there in a minute. But let's see, y1 goes here and here, and then y2 goes here and here. So then we're passing in 100 and 300, and everything should look identical, and it does. Cool. By the way, if I remember correctly, we are actually looping at like 60 frames a second on there. So I'm going to put this in here. Yeah. I guess it still looks the same, but it should be like processing less, which is nice. Okay. So we've got our first swoosh. Let's make a couple more, yeah? Let's do like a swoosh from, I don't know, 200 to 200. It's just a straight line. We can do better than that. There, just a little bit of a swoosh. Add another one that's like 600, 700, way down there. Cool. And then we can do like 500 and 200, like cross that. Yeah, like I think these are starting to look kind of like the mock-up that we did. So that's cool. So I think now we need to, like, instead of just hard coding this, we need to move this into a data structure, and then we need to do random stuff with the data structure. Ooh, actually, I'm kind of jumping ahead here. The reason I think we want a data structure for this is because I think we want these kind of uniformly spaced. Like, I think we want to choose the numbers carefully and then shuffle them rather than just like picking a totally random number between this point and this point. So I think I'm going to jump straight to that. But you can see how like we could do it that other way. It would just be like a little, like it. I don't know. There are different pros and cons to that aesthetic. So what if we say something like this? We'd say like left positions. And now I'm just going to grab all those same things. 100, 200, 500, 600. And then we're going to say right positions equals 300, 150, 200, 700. And now we can have a loop where we're iterating over these, and we are drawing a swoosh for each pair. Let's see. Oh, we could just do like we could zip them together and make a pair. Maybe one way that we could do that is we call map on left position, so it's like num comma idx. And we're gonna put this, like, we'll do an array of arrays. Well, or no, we could do this, like left colon num right colon right positions at idx. And I think, yeah, we actually need to put parentheses around that. But I think that should work. We actually, I haven't written this in a little while. I can't remember. Yeah, IDX comes after, the index comes after the value. So now we should be able to say, for each of these pairs, we're going to create a swoosh from the left side to the right side. So what I'm going to do here is I'm going to pull out those left and right values from the pair. And then I'm going to say left and right. And we've got funny trailing white space that I want to get rid of. Okay, so this was a refactor. Like, everything here should look identical to before. So I click go, and it looks identical. Cool. Okay, so at last, like, we've got our data. Now we can actually randomly create this data. So maybe what we do, let's see, is there like a range function in here? Set range, what is this? Oh, this is like the audio extension. Okay, so that's not what we want. Let's just write it. So I want a function that's basically like, give me, oh, hold on. I just realized that the music stopped. We're gonna press play again. Dope, we're back on. We're learning, you guys. We're gonna figure out how all the audio stuff should work through my headphones, and then the quality of our lives will increase. Okay, but we want a function where we just say like, give me all the numbers up to 5, or like give me 5 numbers. and we want to get back an array of those numbers. So I think what we can do, we can take our for loop. Where's my cursor? Make an array of results, and then we can push into that array, just add more things, right? Push I into that array, and then return it. Results, there we go. So we have a range function, and now this is nice because we can do like a bunch of cool functional programming here. So we can say like range, there's 4, I guess, so far, 4 swooshes. And then we can say .map, and we'll map the IDX to, I guess, and here we're going to do like a little bit of algebra, I guess, to kind of position things where we want. So maybe we want to say like IDX times 100, space them out from each other by 100, and then add another 100. All these need to turn into constants. But now, positions. Yeah, I like how that's formatted. But now we want to call shuffle on it. And if I remember, yes, P5 has this, so that is good. Now, so you pass in an array to shuffle. Does it return? Yeah, I mean, it looks like it mutates the array in place. So if we would just say shuffle left positions. And then we would do the same thing for right positions. And then we would shuffle the right positions, which means that these are no longer needed. But at this point, we should have some cool randomness. Okay, looks like shuffle is not working the way that we thought. Oh, look at that. So it does actually return a shuffled array. So yeah, maybe we just do it like that. I guess we'd have to wrap the whole thing. No, see, we have to, like, this is where we have to keep ourselves honest about like functional programming and immutable data structures. So yeah, I think I'm gonna do it this way. The alternatives, right, are we could just say true here, like, hey, mutate left positions. The other alternative is we could like wrap, shuffle around everything. Honestly, maybe that's a cleaner thing to do. Maybe it's like more clear what we're doing. So that would look like this. Yeah, and I think that's not crazy. Honestly, this might turn into a function. So, yeah, let's do that. So now at this point, I think we're actually like shuffling the array. And at this point, look at that. Oh, cool. I like the convergence. There are like not a ton of combinations when you only have 4, right? I like that one. That one looks pretty cool. But now we've got some randomness. Now we can start to like scale this thing up. So let's make some things into variables. Let's say like swoosh count. And right now it's 4. I think we can fit another. Well, actually, let's pack them tighter. So let's do like 20 swooshes, and then let's do like swoosh. Okay, we need like the top margin and then the in-between margin. So you can do like 50 on the top, and then we can do like inner. And I mean, maybe that's the same number. I guess we can find out. But now this will be easy to just tweak this. Let's see. So this is just a constant. So that's our top margin. And then IDX times 100, that is this. Margin inner. Nice. Okay, so I think we're getting somewhere. I think we need to put some more top padding here, right? Or more top margin, because we're bumping into this. So let's change this to like 100. So now that looks better. We've got too many. So what is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then 14, but really 13. Yeah, so that like barely fits. I think we can get more clever later and like calculate this based on all this other stuff. So we can say like, well, given the canvas size and then the other margin, there's like this amount of space left over that we can fit swooshes inside of, and then like center those swooshes vertically. So we can eventually do that. I think I want to try, I don't know, maybe we pack them a little tighter, see what that looks like. So maybe we try like 25 between each. Okay. So I think, I don't like it. I think it's like too busy through sections. So maybe we don't want to pack it so tightly, but maybe that also means we want to get more clever about how we shuffle, which I think we don't have time for today. But you can probably imagine where like, let me resize this again. We might do something where we've got our array of positions, and we could say like loop over it a bunch of times, and every time you loop over it, maybe switch a few. It'd be like a bubble sort gone wrong. Oh, add margin top and outer margin on lines 25 and 29. Yes, I think the stream might be ahead of I think the stream is probably several seconds behind. What are you saying? Oh, no. I see what you're saying. Outer margin. So basically, instead of interpreting this as the distance from the very top of the canvas to here, we interpret it as the distance from here to here. Yeah, that's a good idea. So yeah, let's see. We actually want to say swoosh margin top. We can set this back to 50, but then we'll also grab this. Outer margin though. What are we using for outer margin? I've already forgotten. No. Outer margin is that like. Yeah, it's that vertical spacing. Yeah. So you can like scale that back and forth. This will move like relative to the edge of that. So I like that. Cool. We should also like make these a constant, because I think this is actually something that we can play with a little bit. Swoosh. Whoops. This should be const. It's like swoosh control point distance, or maybe just control distance. And right now it's 200. So we'll put that there. This will look the same. But now we can like change how forcefully it swooshes. to get real technical, of course. So like now you see these like tiny little bends, right? And so it's almost a straight line. But we could change this to something really dramatic. I like that. I think that looks pretty cool. Maybe we go even heavier. Yeah, I like that. I like this sort of like, you start to get almost this like hemisphere or like, you know, half circle appearing on the edges. So I think that looks cool. I kind of like how that's dialed in. And now this is the great part because we can just like hit refresh, and just like enjoy it. I think this is cool though. I think we made a good thing. We got the convergence going on. I think there's plenty of other like tweaking we could do. One thought that might be cool is like, you know how you've got different colors of patch cables. You could do like maybe like really thick lines, but then some of them are actually empty. We'd have to figure out how to do the math on that. I'm not sure. Because you'd probably have to draw like two parallel Bezier curves. But it's not exactly Bezier, or it's not exactly parallel. Like you can't render a curve and then another curve like shifted up from it, because the thickness of that is not going to be consistent. You actually have to like move every point. And I don't think it's just trigonometry. I don't think you can just like guess on an angle. I don't know. That somebody tell me how that actually works. But that's something that we could do, is like have like a filled in swoosh and an empty swoosh. Maybe making the swooshes thicker would look cool anyway. I think it's stroke width, isn't it? Stroke weight, there it is. Stroke weight. That feels a little Fisher-Price to me. Yes. I think I like that. I think I might be getting distracted by like aliasing that's happening around here. Maybe. There's like just a little bit of that aliasing, and so you notice it maybe a little more at 3. I wonder if you could do like 2.5. Does that look all that different from 3? Yeah, I think that does. I don't know. I like 2.5. I think that looks cool. And I mean, if we were to really make this, then like we'd basically, like, instead of rendering it to a PNG, which is like a fixed amount of pixels, you get aliasing, that kind of stuff. Instead, we could probably like render it out to an SVG, send it to a CNC mill or a laser cutter, and then like, you know, actually cut this. And we wouldn't see any aliasing at that point. I guess we could see aliasing if the stepper motors were like not very good. But like machines like that are really good at making curvy lines. Like they know how to do that stuff in like a smooth, fluid way. So yeah, I think like the end game for this would be like send it to a machine, actually like make this out of wood. Which, like, how cool would that be? Like, you know, you've got like your generative art on a beautiful piece of wood in your synthesizer. You're gonna make so much more music with that. But yeah, I think this was cool. Like, we made a cool thing. We should save this. Let me, am I logged in? I'm not logged in. Okay, so copy the code just in case. And then I'm gonna log in with GitHub, because I've already logged in that way. And I should have, yeah, I've got a bunch of cool stuff in there. So now I can paste it again, get the same answer. And now we can rename it to Eurorack blind panel. Oh yeah. I'm gonna end the stream here, but I'm just gonna keep clicking on this once I'm done, you guys. Oh yeah, this is great. I love it. All right. Well, I think this is a good stopping point. So, switching back over. Yeah, I think this was a cool first stream. Thanks for bearing with me during the weird technical difficulties. Like, we finally got the stream up and running, and we've got audio, even though like I can't particularly hear it, or else it's like delayed. We'll fix all that kind of stuff for next time. But yeah, this is really cool. I'm really excited to be doing this. I think it'll be really fun. I think I'll learn stuff. Hopefully you'll learn stuff as well, and it'll be a cool way to kind of pay it forward, share ideas. Should be awesome. Yeah, thanks so much for watching. See you next time.